idea of this is exponential equation higher cases, where you are going to be given 3 exponent x equal to x exponent 9, and you are asked to find x. Please mind you, this case is the same as question 2 and that of question 3. So you are going to use the idea of this in solving this. So you pay attention to this question so that you can get the idea in solving this question 2 and this question 5. So it's very simple. Watch here. Alright. You have 3 exponent x equal to x exponent 9. In this case, the base are not the same, neither the exponents are also not the same. So what you're going to do here is you are going to take log of base 3 to both sides of the equation. Log of base 3 to both sides of the equation. The same thing applies to this. For this question too, if you are introducing log, what will be the log base? Because you are dealing with base 4, then the whole thing is going to be, you are going to take log of base 4 to both sides of the equation. When it comes to the same thing, we have base 1 5, so we are going to take log of base 5 to both sides of the equation. The same thing is what I'm using in solving this. So watch here. Taking log, so it's going to be log 3 exponent x base 3, because we are taking log of base 3. So log 3x base 3 equal to log of base 3, and the log number is x exponent 9. So from here, then it's going to be x log of 3 base 3 equal to log is 9 log x base 3. From here, we can write this as x is equal to 9 log x base 3. 9 log x base 3. Why? Because we said earlier on that log of a number to the same base under the properties of logarithm, here is going to be what? 1. So 1 times x will give you x. Because we said earlier on that log of a number to the same base, if the number is the same as the base, then from the properties, the whole thing will turn 1. That is why we are getting x is equal to 9 log x base 3. But watch here. With this one, the log number is not the same as the base. So in that case, the property is not working here. So how do we solve for our x here? But remember, on both sides of the equation, on both sides of the equation, you could see that x is on your left side and x is on your right side of the equation. So you say that let the x you are seeing represented by 3 exponent p. 3 exponent p. 3 exponent p. Why? Because the reason why we choose 3 is because the log is given in base 3. So if you want to represent your x with any other number, then you consider the log base, which is 3. That is why we are choosing 3 exponent p. So what it means here is we are going back into this equation. Whenever we see x, we are to substitute the x with 3 exponent p. So watch here. We are getting 3p is equal to 9 log 3p. 9 log 3 exponent p base 3. So the whole thing has 10. Whatever we said earlier on that whenever we see x, we have to substitute this x with 3 exponent p. So this is what is happening. That is why we are getting this. Because we said wherever we see x, we have to replace this x with p. We have to replace the same x here with the same p. That is why you are seeing 3 exponent p on your left side of the equation, the same 3 exponent p on your right side of the equation. And from the properties of logarithm, we can write this as, because this is attached with logarithm, the power can be a coefficient to this. So we are getting 9p. Log 3 base 3. Why? Because I've moved this power to the 9. That is why we are getting 9p. So it is left with what? Log 3 base 3. So from this, we can see that 3p is equal to 9p. Why? Because log of a number, we said it earlier on, log of a number to the same, if the number is the same as the base, then everything here will turn 1. So 1 times 9p will give you 9p. So you ask yourself, what number when you put here, it will give you the same as this? So we don't know the number, so we can test it by starting with, when p is 1, then I'm getting what? Is equal to 9 times 1. And so the left is not the same as the right. So our p as 1 is not, can be the answer. Then you test it. You go for it with another number. So when p is 2, meaning when p is 2 means whenever you see p, we are replacing the p with 2 so that the left will balance the right. That will be the solution set. So what? When p is equal to 2, then it's going to be 3 exponent 2 equal to 9 times 2. So here will give you 9, here will give you what? 18. The left is not the same as the right. So in that case, our p is not 2. The left is not the same as the right. So in that case, our p cannot be what? 1. So let's test another number. When p is 3, meaning when p is 3, then we have to put this p here, meaning wherever we see p, we have to substitute with 3. So what here? Whether the left will be equal to the right, let's check. So 3, we said your p is 3, so p is equal to 3 equal to 9 3. So 3 exponent 3 will give you 27. 9 times 3 will give you 27. So it tells you that your x is 27. Your x is 27. So 3 exponent 27 is the same as 27 exponent 9. When you use your calculator to punch, the answer you're going to get to your left will be the same as the answer you are going to get at your right. So it tells you that your x is 27. Using the same idea, the same methodology, you can solve for question number 2 and at the same time question number 3. So what I did is I introduced log of base 3 to both sides, because our base here, our numerical value, which is a number which we see as our base, is 3. So if I want to introduce logarithm, then it's going to be log of base 3. If here happens to be 7, if the question was set in such a way that here was 7, the base is 7, then I'm going to introduce log of base 7. That is the brain behind it. Without this idea, you can't solve it. You can't. So in our case here, it was given, the question was set as base 3. So if I'm introducing log, then it's going to be log of base 3. So I will take log to left and introduce log to right. So log to the left side, that is why we are seeing this. Log to the right side, that is why we are getting this. Log of base 3 to left and right. And from the properties of logarithm, log of a number and the number is having an exponent or power, then from the properties we can rewrite this as x log 3 base 3. Meaning I've placed the power in front of the log. It's a property and it works. So it's going to be x log 3 base 3 equal to the same thing, log of a number, and the number is having a power. Another way of writing this is by putting the 9 in front of the log. And this is what we are seeing. So from here, from this step, we are getting this. Why? Because log of a number, and the number is the same as the base. Everything here will turn 1. So 1 times x, like this, 9 log 3, blah, 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 in that order. So from here, we are solving for x, and we don't know the behavior of x. We don't know the behavior of x. So what we are doing here is, we have left at your left, we have x at your left, we have the same x at your right. Then we say that let x be equal to, what base were you given? You were given 3. Then you write it as 3 exponent, any number. So we don't know the number, so I will let p be my number. So let my x, I'm going to replace on both sides, be represented by 3. So what it means here is, if here happens to be base 5, then I will say that let x, because the base given is, the log base is 5, then I'll write this as what? 5 exponent p. 5 exponent p. That is how the trick is working. That's how the trick is working. So because in my question it was given in base 3, so in my let, I will say that let x be equal to 3p. So meaning I'm to put x, I'm to replace this x with this, the same x here with the same here. That is why you are seeing this. So one may say well, from the 3p, well, from this p, 3p you are writing here. You said, you made earlier statement saying that x is equal to 3p, meaning whenever we see x, we are to replace this x with 3p. That is why in my next step, x has been replaced with 3p. When you come here, log 1, this x has been replaced with 3p. So with this, then this one is a property, log of a number to this, to the power, meaning we can let the power be a coefficient. That is why we are getting the 9p here, so that this becomes a property for us. So that at the end of the day, this 3p will be equated to this. That is why we are getting 3p equal to 9p. Say, well, from why we are not, where is the log? Why? Because log of a number to the same base, everything here will turn 1 is a property. And you need to know under logarithm. So log of a number, and the number is the same as the log base, then in the property we say that everything here is 1. That is why. So we test with raw numbers, natural numbers starting from 1. So if it is true that our p is 1, then the left should balance the right. But with our case here, the p cannot be what? 1. That is why p is not 1. So after testing 1, you move on to the next natural number, which is 2. So if it happens that my p is 2, meaning if I'm to substitute this p2 here into the original equation, the left should balance the right. But with our case here is 9, the other side is 18, meaning the left is not the same as the right. So our p cannot be what? 2. Then the next natural number after 2 is what? 3. So mean I have to put this 3 here into the original equation. So 3, he said we shouldn't be 3. That is why we are getting this 3 here equal to 9. That is why we are getting this, because we said p is 3. So after let's simplify. 3 exponent 3 will give you 27. 9 times 3, so the left is equal to the right, then meaning our p here is correct, because the left has balanced the right. Let's test it. Let's see what will be the true solution to our x. We said x is equal to 3, and we solve our p as 3, so 3 exponent 3 is 27. That is why the solution is 27. Use the same idea. Use the same idea in solving question 2, question 3, and comment your answer below. Please, with all due respect, subscribe to the channel. Subscribe for more videos. We have a lot of videos to share with you guys. Subscribe, you share on your social media platform. Put Zoley Online Mathematics to a shape, and God will bless you. Thank you very much for having time with me.
チャンネル登録してほしい。